Okay, so here's some more examples out of 11.3. And we just want to simplify these things, right? So basically we're just warming up logarithms. Okay, so what does the logarithm base something ask? In other words, what question is this thing asking about 10 to the 1.3?
Isn't it like what to the 10th power equals 10?
Okay, so
It's kind of like backwards.
it's kind of like, so this thing's asking, what power of 10 is 10 to the 1.3?
1.3.
Yeah, good. This is an easy one, right? Because the base here matches the base of the number here, right? So I just say, okay, this thing rips off the power. This is 1.3. Another way we could think is log base 10 and 10 to the stuff are inverse functions. So I could cancel those and get 1.3. You guys follow that? Those are inverse functions, so they undo one another. Cool? All right, how about this guy? Log base 9 of 27. What do I do? Okay, I know something about 27, right? So this is the same thing as log base 9 of 3 cubed, right? Am I ready to get an answer out of this thing? Not quite.
So you have to make the bases.
9 is 3 squared.
Yeah, 9 is 3 squared, right? So specifically 3 is the square root of 9. You guys see that? I need to turn these into 9s to a power, right? You guys see that? So I could replace 3 with square root of 9.
So it's 3 to the 3 over 2.
So this is log base 9 of 9 square root cubed. Right? These are the same thing. Then I could say, okay, this is log base 9 of 9 to the what power? 3 over 2. Or 1.5, yeah. And this is, so now this is asking what power of 9 is 9 to the 3 halves? The answer is 3 over 2. Another way that we could see that is if we went back up here to where we said 27 was 3 cubed. We could say this is log base 9 of 9 times 3, right? Which is multiplicatively 1.5 nines. Right? That's me thinking this is log base 9 of 9 times square root of 9. So if I was kind of counting 9s, there's 1 power here and half a power there. That makes my 1.5 powers here. You guys see that? That's a bit more subtle. This is, I hope, relatively straightforward, but maybe not something you would see. This is not an easy problem, right? Okay, how about this next guy?
Can't do it.
Why not? Why can't I do it?
Because even if 2 to the 0 is just 1.
Okay, so
There's
2 to the
nothing
0
that
is
you
1,
could-
but somehow convince me that I can't get.
You can't put 2 to any power to get 0.
Yeah, very nice. There's no power, so that 2 to that power is 0.
Well,
Right? Because I'm still multiplying some 2's together. Yeah, okay. Maybe if I allowed infinity or minus infinity to be on my number line, then maybe 2 to the minus infinity would be 0, right? But that's not a number, so this is undefined.
Does anybody come up with a symbol on the top? Or do we just use negative
This one gets used sometimes.
DNA?
Yeah, which I don't really like to say here because D&E has some connotations as to why it doesn't exist that are usually calculus based, and we're not actually doing calculus here, right? So I prefer undefined here. D&E is also fine if you want to use a shorter
Like
set.
the D and E all together in like one weird square shape that makes them. It won't
No,
make sense.
please don't do weirdness like that.
I have a question. Okay, on the last one, I think I didn't catch why you put 3 over 2, 9 to the 3 over 2.
Okay, so this is square root of 9 to the
To the
third,
which
right?
is 27.
And then that's 9 to the 1/2 to the third. And I multiply the powers.
9 to the 1/2.
Remember the square roots, the 1/2 power.
Oh, okay, gotcha.
Yeah, those are going to keep
So that's the
coming
same
back
thing
to
as
bite
that.
you.
Okay.
Cool? You guys all remember that out of 10.5? Those are going to continue to come back and
Yeah.
bite you.
Okay.
All right, so how about log 0 of 2?
Can't do it, they're gonna need to multiply 0 by to get 2.
Yeah, there's no number of zeros that I can multiply together to get 2, right? At best, I could go for undefined, right? Zeros multiplied together are either going to be 0 or undefined, right? I'm not going to get 2, right? So that's just not an option. So this one's also undefined. How about log base pi of pi?
One.
Yeah, I don't ever think that, right? That's log base something of something. That's going to give you 1 every time.
So basically, if it has 0 on either the log or the number of parentheses, it's going to be undefined.
What if it's 0 on both?
It sticks
Great
to
question.
itself.
What if it's 0 on both of
Because
them?
0
So
to the
hard.
0 power is.
This one's weird, right?
That's annoying.
Because this is asking how many zeros you got to multiply together to get 0.
One.
Basically, any number of zeros multiplied together is 0, right? So this would be,
All real numbers.
yeah, it won't be all real numbers because negatives definitely don't work, right? And 0 doesn't work. But this could be any positive number.
But
You see that?
negatives work with this. Because
Oh, because 0 to the negative 1 isn't 0. It's undefined. Does that make sense?
yeah.
Okay, so the negatives at least don't work. But any real number, any positive, strictly positive real number would work. 0 to the 0 still doesn't make any sense, right? So, this is problematic.
That.
This is this is a thing I was hoping was a function that I was hoping to do to an input, right? And it gave me not only a couple outputs, but lots of infinitely many outputs. This should tell you that log 0, right, log base 0, isn't a function.
So why create?
It's an idea, but it's not a function.
Why create an idea or number of an O or 0 that has so many problems?
Have to have it. You got to have something you can add to something. Leave it alone. You need an identity addition function. But yeah, it does cause some problems. This is good. This is good motivation actually, not to not invent 0, but to not invent multiplication, because that's really the problem we're having.
Instead of multiplication, just add and subtract everything together. But then you come up with more problems than that other problem, because you have to solve those problems, then you have to do multiplication again anyway.
Yeah, it's fraught with difficulty.
Take a breath.